Okay. Our chapter that we are beginning today, the chapter that will take us through the end of this semester, is all about solving a system of linear equations. And a system of linear equations is just a set of linear equations. I gave you a set of linear equations on each of these whiteboards over here. Okay? Okay. Now, I am going to ask for the solution to a set of linear equations. Now, I will tell you that the solution is a coordinate that satisfies each equation. Now, technically what I asked you to do without you knowing it, I asked you to find the solution to the system of equations. So let's just look up here at group 2. They graphed me these two lines. If I asked you, hey, what's the solution? What do you think that would be? M?
The area where they meet.
Ah. So what? Intersect. So that intersect point right there?
Yeah.
Yeah. So we are looking for where these two lines intersect. Huh. Cool. When I give you two linear equations and I say, find the solution, I am literally asking you, hey, where do these two intersect? And when we find that intersection, that coordinate should go into both equations and work for both. Let me show you what I'm talking about. Okay. On the next page, I want you to look at number 7. Okay. In number 7, where do these two lines intersect? Right here, 2, -2. So the answer, the solution to our system of linear equations is 2, -2. That's where they intersect. Now, if this is really, indeed, the solution, then this coordinate should be able to get plugged into both equations and it should work. So I have a question. Is 3x minus 2y equal to 10? So I took x is 2 and plugged it in. I took y is -2 and plugged it in to that first equation. Is 6 plus 4 equal to 10? Okay. Now I'm going to do it for x plus y equals 0. So again, x is 2, y is -2. When I put x plus y, is 2 plus -2 equal to 0? Okay. So that coordinate, yes, is the solution. Number one, it's where the two lines intersect. Number two, we checked it and it works for both. Okay, what I want you to do, find me the solution to number 8 and check it. Find me the solution. You know what, let's do 9 just so we have more room. Find your solution to number 9 and check it. Jace, what's our intersection point?
4, 2.
Okay, so 4, 2 is the solution. Okay. When we plug it in to the first one, x plus 2y, does that equal 8?
Yes.
Okay. 3x minus 2y, does that equal 8?
Yep.
Okay, that's good. Okay, what's really, really nice about basically what we're doing all week, all the way until Thanksgiving break, honestly, you can check your answer to see if you're right. Because the coordinate that you get, x comma y, you can plug it into both, and if it works for both, you have the right answer. Isn't that great? I think it's great. Huh, some of these look familiar. Right? Okay. Number 10, raise your hand if at your group you graphed these two lines. I think it was group 1 and group 4, right? 5, group 1 and group 5, sorry. Okay, so let's graph these together. Y equals mx plus b. And I'm going to just underline this one in pink. In our pink line, what's our y-intercept? Our y-intercept is 3. And our slope is -1. So down 1, right 1, down 1, right 1. And then our second line, we have a y-intercept of 5 and a slope of +1. Okay. Now here's the deal. I am looking for where these two intersect. So I need to make sure that when I count my slope, I make it to the other line. So I counted my slope up 1 over 1 to get to this point. But that's not going to help me get to the line, is it? I almost need to count my slope backwards. So if I'm going to count a slope of 1 but go backwards, then I can go down 1, left 1. Oh, hey. I made it to that line, didn't I? Okay. I think it's really important for you to be able to count your slope both forward and backwards to make sure that your two lines are going to intersect at that exact point. So what is our line of, what's our point of intersection? Negative 1, 4. This is our solution. Okay, that's our solution. Okay, I guess we better check. Is negative x plus 3, does that equal 4? Yeah, it does? Okay, and then does x plus 5 equal y? Okay, good, so we're good to go. All right, could you please graph number 11 for me? Some of you already have. But do it for real on here. What are you getting as your point of intersection? Negative 2, 3? Okay. Because for line number 1, we start at 2 and go up 1 over 2, up 1 over 2. And then for line number 2, we start at 4 and go, oh my goodness, down 1 over 2, and we intersect just right there, right? So that's at, isn't that at 2, 3?
Yes.
Okay.
Wait, if the negative shows a negative x, that would be the negative slope.
Yep. Okay. So, okay. So, like, I want to talk about 14 because I had 2 groups graph it, but they didn't actually draw it to where they intersected. Okay. So, like this right here, what's our y-intercept? Our y-intercept is 3, and we're going to go up 1 over 4, correct? So I had a lot of people, like, do this. Okay. Oh, man. Okay, so it's going to go off the paper. Let's problem solve. Instead of going up 3 over 4, and it's going to go off the paper that I have, what's another way we can graph another point? Instead of up 3, right 4, what are we going to do, Ella?
Down 3,
Down 3, left
left 4.
4. Okay, well now I better go back to my green line, my first line, okay? We probably need to do the same thing there. I counted my slope up 1, right 4 to get to this point, but I probably need to go backwards to make sure down 1 over 1, 2, 3, 4. Oh, good. Okay, my slope is going to count to where we intersect here at this coordinate, -4, 2. Okay, we are sometimes going to have to count slope forwards and backwards. Okay, and no matter what do we need to be doing with our coordinate? Checking it. 1/4 times -4 plus 3. Does that equal 2? Yep. 3/4 times -4 plus 5. Does that equal 2? Okay. Now, one more problem. We need to remember how to graph a line like this. So we're going back to number 12. You have 2 options. You can solve for y so that it's in slope-intercept form, but there is a greater chance for error, like some of you on your test. Some of you lost like negatives and positives when you solved for y this way. If it's in standard form, what's the other way that we know how to graph these? M. X and y intercepts. We can plug 0 in for x. Oh, what's 3 times 0?
0.
So our y-intercept is -3. We can plug 0 in for y. Oh, hey, what's 2 times 0? So our x-intercept is 2. Okay, that is the second method that we learned to graph lines. Yep, everything builds on each other. Now, ooh, how do we graph this line? Miles? Here's -3. So here's a -3 and here's a -3. I need you to be more specific. I know you know it. Which -3 do I want? Zoe? The one on the what axis? The one on the y-axis. Y equals a number is a horizontal line. Yay, what's our intersection point? 0, -3. And guess what we can do? We can plug it in, we can check. Okay? Okay, literally, we are taking our concept of graphing lines from chapters 3 and chapters 4. And we're graphing 2 lines at once. And what are we looking for? Where do they intersect? That's it. Okay? What do you need to do with the coordinate when you find where it intersects? Plug it in to check. Is 3 times x minus 2 times y equal to 6? Plug it in and check. Okay, I have put graph paper at your table.